Learning objectives. In this chapter, the user would learn the following in detail: drive, film transport, gate, lenses, back focus, claw and registration, components and properties of camera, basic principles of photographic representation, close, long shots, response function of a camera, CCD cameras, 1 CCD, 3 CCD, etc., and their usage, optical and geometric properties of lens, depth of field, basic structure, pinhole camera model, wide-angle lens, telephoto lens. Introduction. What is a camera? A camera is an optical instrument that records images that can be stored directly, transmitted to another location, or both. These images may be still photographs or moving images such as videos or movies. The term camera comes from the word camera obscura, Latin for dark chamber, an early mechanism for projecting images. The modern camera evolved from the camera obscura. The functioning of the camera is very similar to the functioning of the human eye. Functional description. A camera may work with the light of the visible spectrum or with other portions of the electromagnetic spectrum. A still camera is an optical device which creates a single image of an object or scene and records it in an electronic sensor or photographic film. All cameras use the same basic design. Light enters an enclosed box through a converging lens and an image is recorded on a light-sensitive medium. A shutter mechanism controls the length of time that light can enter the camera. Most photographic cameras have functions that allow a person to view the scene to be recorded, allow for a desired part of the scene to be in focus, and to control the exposure so that it is not too bright or too dim. A data display, often a liquid crystal display (LCD), permits the user to view settings such as film speed, exposure, and shutter speed. A film or video camera operates similarly to a still camera, except it records a series of static images in rapid succession, commonly at a rate of 24 frames per second. When the images are combined and displayed in order, the illusion of motion is achieved. Drives. Motor drive. A motor drive in the field of photography is a powered film transport mechanism. Historically, film loading, advancing, and rewinding were all manually driven functions. The desires of professional photographers for more efficient shooting, particularly in sports and wildlife photography, and the desires of amateur and novice photographers for easier-to-use cameras both drove the development of automatic film transport. Some early developments were made with clockwork drives, but most development of the field has been in the direction of electrically driven transport. Film transport. An adequate film transport system needs not only to satisfy the demands of manual film advance, but also withstand the punishment of continuous motorized shooting of up to 3.5 frames per second, as well as provide for intentional, accurate registration, double or multiple exposure operation in either mode. The FM-FE's film flatness and positive film travel with such a low torque was a vast improvement over the earlier Nikomart, perhaps even smoother than the Nikon F2, but not the F3. The F3's film advance action is by far the most impressive among all the manual focus Nikon cameras. There is even a precisely positioned film plane indicator in one type. The film advance mechanism coupled frame counter, the smooth action film rewind mechanism, and a unique provision for double or multiple exposure operation form the basic in the camera film transport mechanism. Film gate. The film gate is a rectangular opening in the front of a motion picture camera where the film is exposed to light. The film gate can be seen by removing the lens and rotating the shutter out of the way. The film is held on a uniform plane at a calibrated distance in the gate by a pressure plate behind the film. Occasionally, as a film passes through the gate, friction can cause small slivers of celluloid to break off and stick in the side of the opening. This debris is called hairs. A hair in the gate will remain in front of the film and create a dark line that sticks onto the edge of the film frame as the camera is filming a shot. A hair in the gate is also known as a rabbit in the gate. A hair can ruin the shot and is almost impossible to fix in post-production without being painted out digitally. Lenses. Camera lens. The creative use of the lens gives photography its expressive qualities, and you have to embrace it to get your vision properly captured on film or in the image sensor. A primary characteristic of a lens is the focal length. A lens's focal length is defined as the distance between the lens's optical center and the camera's image sensor, or film plane, when focused at infinity. To understand this definition of focal length, we need to define optical center as well. A lens's optical center is a point, usually though not always, within a lens at which the rays of light from two different sources entering the lens are assumed to cross. Shorter focal length lenses provide a wider field of view but offer less magnification. Conversely, longer focal lengths offer a shorter field of view but provide greater magnification. On DSLRs, the interchangeable lens's focal length is measured in millimeters. The focal length of a lens is usually displayed on the lens's barrel, along with the size of the adapter ring. Lens ratio. Primary characteristics. When you look upon the front of your lens barrel, you will see a ratio number, reading 1:2.8, 1:2.8 to 4, 1:3.5 to 5.6, etc., which is the maximum aperture of the lens. The aperture determines how much light the lens transmits to the image sensor. The maximum aperture value will indicate the quality of the lens in terms of brightness. High-quality zoom lenses deliver a constant f-stop throughout the focal range, that is, a f/2.8 at 35 mm and a f/2.8 at 80 mm, whereas on a low-quality lens, the f-stop varies as you travel at the focal range, that is, a f/3.5 at 28 mm, but a f/5.6 at 80 mm. You are losing at least one stop of light as you zoom up the focal length from wide angle to telephoto. A lens with a lower f number, wide maximum aperture, is a better quality lens and allows you to do more with it. For example, such a lens is brighter, allowing you to take photos in low ambient light conditions, yet still register a quality exposure. In addition, these bright lenses allow you to achieve a very shallow depth of field. It is to be noted that any lens that is f/2.8 or lower is considered to be a professional lens and will have a correspondingly higher price tag. Back focus. Back focus refers to the focal flange length. This is the distance between the rear lens element and the CCD. A camera with a back focus ring. It will be located toward the rear of the lens housing. A back focus chart like the one pictured is helpful, but any object with sharp contrast will do. Back focus a camera. How to back focus a camera? Secure the lens to the camera body and plug in auto iris connector. Turn the lens clockwise until it is reasonably tight. Loosen the CS mount ring on the camera body. Face a neutral density filter in front of the lens. This will force the lens iris to open the max, thereby reducing the depth of field, making adjustments more precise. Set the focus to near. Set the zoom to wide. Hold the camera at a high contrast object a distance away and turn entire body of the lens to bring object into focus. Retighten CS mount ring. Remove the neutral density filter. Claw and registration. Pull down claw. To remove the film, a small hook or claw engages into a perforation in the film and pull it through the gate. This small hook or claw is called the pull-down claw. Each camera contains some types of pull-down claw to remove the film. Some of the more advanced cameras, including many 35mm cameras and those used for special effects cinematography, contain two pull-down claws, one on each side of the frame. Registration pin. When the pull-down claw pulls the film into the gate so that it is held perfectly still during this exposure process, a metal pin engages into the film's perforation and holds it in place so that it may be exposed. This pin is called the registration pin. Some 16mm cameras do not have a registration pin, but because of their design, the film is held surely enough in the gate area. As with pull-down claw, some of the more advanced cameras, including many 35mm cameras, such as those used for special effects cinematography, contain two registration pins. Components and properties of camera. Components. All cameras contain the same basic components. Camera lens. The lens focuses the light rays from the subject and creates a reversed, upside-down image on the film at the back of the camera. Aperture. The amount of light reaching the film plane is controlled by the aperture. Shutter. The shutter can be set at different speeds to determine the length of time the film is exposed. Camera body. The light, tight body houses the various components of the camera. The shape of the body is influenced by the type of viewing system. Film. The film records the subject's image on its light-sensitive surface. The film can be either chemical or digital. A transport mechanism is required to replace exposed film with unexposed film. With digital cameras, the image must be converted and stored before the next picture can be taken. Properties. The camera components have a set of properties which alter their behavior. Clear flags determines which parts of the screen will be cleared. This is handy when using multiple cameras to draw different game elements. Background. Color applied to the remaining screen after all elements in view have been drawn and there is no skybox. Culling mask. Include or omit layers of objects to be rendered by the camera. Assign layers to your objects in the inspector. Projection. To simulate perspective. Perspective. Camera will render objects with perspective intact. Orthographic. Camera will render objects uniformly with no sense of perspective. Size. When orthographic is selected. The viewport size of the camera when set to orthographic. Field of view. When perspective is selected. Width of the camera's view angle measured in degrees along the local y-axis. Clipping planes. Distances from the camera to start and stop rendering. Near. The closest point relative to the camera the drawing will occur. Far. The furthest point relative to the camera the drawing will occur. Normalize viewport rect. 4 values that indicate where on the screen this camera view will be drawn. In screen coordinates, values 0, 1. X, the beginning horizontal position where the camera view will be drawn. Y, the beginning vertical position where the camera view will be drawn. W, width of the camera output on the screen. H, height of the camera output on the screen. Depth, the camera's position on the draw order. Cameras with a larger value will be drawn on top of cameras with a smaller value. Rendering path, options for defining what rendering methods will be used by the camera. Use player settings. This camera will use whichever rendering path is set in the player settings. Vertex lit. All objects rendered by this camera will be rendered as vertex lit objects. Forward. All objects will be rendered with 1 pass per material. Deferred lighting. All objects will be drawn once without lighting. Then lighting of all objects will be rendered together at the end of the render queue. Target texture reference to a render. Texture that will contain the output of the camera view. Making this reference will disable the camera's capability to render to the screen. HDR enables high dynamic range rendering for this camera. Basic principles of photographic representation. Introduction. Any aspiring photographer longs to get his or her hands on a great digital single-lens reflex DSLR camera. The wide range on offer proves an arduous challenge. Many brands with a huge array of features and technical jargon we don't fully understand make sifting through the options rather difficult. So in this session we will cover camera specifications that will have you feeling like an expert in no time. Basic features related to photography. Let us study some basic features related to photography. Shooting modes. Aperture priority, shutter priority, and manual mode. Each has its own purpose. Depth of field. This is a measure of how much of the scene is in focus and is most easily controlled by changing the aperture. ISO. This increases the camera sensor sensitivity to light but also increases the amount of digital noise. Focus modes. There is fixed focus and servo focus, as well as a hybrid mode. Which is best to use depends on the movement of your subject. Focal points. Selecting one or several focus points can help you fine-tune your focusing. Back focus. Using the button on the back to focus can help you snap photos faster. Exposure compensation. This is handy for tweaking the exposure values that the camera determines. Custom white balance. If you want perfect white balance, customizing it is your best option. Metering modes. This controls how your camera determines the exposure. Live view mode. This helps for previewing your exposure and fine-tuning your focus. Flash control. Knowing when and how to control your flash is important when lighting your image. The beep. For the most part, this is unnecessary. Customizable menu. For an easier time navigating your menus, you can make your own. Advanced features. Faster operation. All functions of a DSLR camera, from near instant power-up to autofocus to storing an image on your memory card, are likely to operate faster and more smoothly than with other types of digital cameras. Lenses, lenses, and more lenses. Many non-SLR cameras are outfitted with do-everything lenses, but they don't do everything. Only a digital SLR, which lets you pop off the lens currently mounted on your camera and mount another one with different features, has that capability. Better image quality. The DSLR's lenses has larger pixels, which makes them more sensitive to light and less prone to grainy artifacts called noise. More control over depth of field. Digital SLR cameras allow you to choose between shallow and extensive depth of field and everything in between, unlike most non-SLR digital cameras. Camera-like operation. The workings of a non-SLR digital camera have more in common with a cell phone than with a traditional film camera. If you want a digital camera that works much like a traditional film camera, go with a DSLR. Types of camera. Cameras can be divided into videos and still cameras. Video or still cameras are used depending on the purpose. Still cameras. A still camera is a type of camera used to take photographs. Traditional cameras capture light onto a photographic film. The digital camera represents an integration of optics, mechanics, and electronics consisting of 3 layers. The top and the middle layers are printed circuit boards, PCBs, which contain most of the electronic components. The bottom layer houses most of the mechanical components. Digital cameras use electronics, usually a charged coupled device, CCD, to store digital images in computer memory inside the camera. The digital image can be transferred to a computer for later processing. The word still here means not moving or in motion. Still photography means pictures that are still, in contrast to motion pictures or movies. The digital camera and film camera that we mention here are digital still camera or 35mm still camera. The opposites are a digital video camera and a film movie camera. This defines a subject that will be covered in this camera guide. Video cameras. A video camera is a camera used for electronic motion picture acquisition, initially developed by the television industry, but now common in other applications as well. Compact digital cameras have been able to capture short video clips for many years. These movie modes have been more than sufficient for sending as email attachments and web use, but for a long time they weren't of high enough quality to do much else. The good news is that a new generation of cameras, both compact and SLR, has arrived that's capable of capturing high-definition video almost as well as it can capture high-resolution stills. The concept of a single camera that does it all is certainly appealing. Just imagine going out on a shoot and being able to switch between capturing stills and a high-definition movie at the flick of a switch. Well, this is now possible. In 2008, Nikon introduced the D90, the world's first DSLR camera, capable of capturing high-definition video, since when it has been joined by a slew of models from other SLR manufacturers. Although some professional DSLR cameras are able to shoot stills at up to 10 FPS, This rate is nowhere near fast enough for movies and produces jerky video. Smooth action video needs to be shot at 25 or 30 frames per second, and current DSLR cameras can't flip the mirror up and down that fast. To get around this problem, the latest generation of cameras either keep their mirrors up and capture video in a live stream from the sensor, or in the case of interchangeable lens system cameras, do away with the mirror entirely. What we'll call HDSLR, high-definition single-lens reflex cameras, use the sensor's live view functionality to capture video. Many high-end compacts now offer some form of HD movie capture, usually 720p, and many of the major manufacturers have introduced at least one DSLR or other interchangeable lens system camera with HD movie capabilities. Video in a DSLR and large sensor cameras brings a wealth of creative possibilities, including the ability to control depth of field and exposure and to use exotic lenses for effects traditionally the preserve of the professional videographer. Close and long shots. What is a close-up shot? A close-up in filmmaking, television production, still photography, and the comic strip medium is a type of shot which tightly frames a person or an object. Close-ups are one of the standard shots used regularly with medium shots and long shots, cinematic techniques. Close-ups display the most detail, but they do not include the broader scene. Moving into a close-up or away from a close-up is a common type of zooming. What is a long shot? A long shot, sometimes referred to as a full shot or a wide shot, typically shows the entire object or human figure and is usually intended to place it in some relation to its surroundings. It has been suggested that long shot ranges usually correspond to approximately what would be the distance between the front row of the audience and the stage in a live theater. Response function of camera. We estimate CRF through weighted least square error minimization. The minimization formulation is flexible in the sense that we can estimate CRF using one or more single-channel images which share the same CRF. The plots show the estimation results respectively using 1, 2, and 4 single-channel images. Estimation is more accurate when more images are available. CCD cameras and their usage. In a single CCD camera, all of the color spectrum is recorded by one sensor. In most cases, this is done by means of a Bayer-type array filter, a grid of green, red, and blue filters. There is usually twice the number of green pixels than red and blue. The CCD basically records a full-resolution grayscale image and the colors added at the processing stage. 3CCD camera. A 3CCD camera is a camera whose imaging system uses 3 separate charge-coupled devices, each one taking a separate measurement of the primary colors, red, green, or blue light. Light coming into the lens is split by a trichroic prism assembly, which directs the appropriate wavelength ranges of light to the respective CCDs. The system is employed by still cameras, telecine systems, professional video cameras, and some prosumer video cameras. Optical and geometric properties of lens. Optical characteristics. The lens has a gradient refractive index, and the proportion and direction of scattered light depends on the steepness of the refractive index gradient. Geometrics. The primary lens geometrics for the positive lens elements illustrated in figure are biconvex and plano-convex, having one planar or flat surface. In addition, the convex meniscus has both convex and concave surfaces with similar curvatures, but is thicker in the center than at the edges. Negative lens elements are the biconcave, plano-concave, with a single planar surface, and concave meniscus, which also has concave and convex surfaces, but with the center of the lens being thinner than the edges. Depth of field. Depth of field, DOF, refers to the range of distances from the camera at which acceptably sharp focus can be obtained. This is a very important concept in video work for 2 reasons. You really need to understand DOF to have full control over your focus. If you don't know how DOF works, then sooner or later you will end up with the soft footage that could otherwise have been saved. Knowing how to manipulate DOF opens up a massive range of creative possibilities. Basic structure, pinhole camera. Pinhole camera model. The pinhole camera is one of the simplest cameras possible and has the three components necessary for making a photographic image. First is a light-proof box for holding the film. Second is a light-sensitive material fixed opposite. The third component, a hole that light passes through to expose the film. There is no lens. The aperture is created by punching a small hole opposite where the film is mounted and is very small, and the shutter is controlled manually by uncovering and covering the opening. Despite its simplicity, it still has many enthusiasts because of the unique pictures it creates and the imaginative ways of turning ordinary objects into pinhole cameras. The camera is very easy to make, but to take pictures with it, one will need access to a means of developing the film. The principle is identical to the pioneering camera obscura experiment. Typically, a light-sealed container like a biscuit tin or a matchbox can be used. Wide-angle lens. A wide angle has a shorter focal length, 10 through 42 mm, when compared to a standard lens. This enables you to capture a comparatively wider angle view. A wide-angle lens is a natural choice for capturing outdoor landscapes and group portraits. In fact, wide-angle can be the only way to capture complete setting without omitting any important elements in the image. In this manner, you can use wide-angle lenses to capture a deep DOF. Wide-angle. Wide-angle lenses have a large field of view than normal lenses. In other words, they capture more of the scene in front of the camera by capturing more of the peripheral scenes. However, as the size of the film in the camera is still the same, the wider scene appears in the film as being slightly distorted. The bigger scene is squeezed onto the same area of the film, so the typical effect is that each object is smaller and therefore looks farther away because the film now includes more objects. There are various wide-angle lenses measured by the focal length. The normal lens for 35mm camera is about 50mm focal length, and a wide-angle lens has a shorter focal length such as 35mm or 28mm. The shorter the focal length, the greater the perspective distortion. At the extreme end, there are wide-angle lenses with a focal length of 10mm or so, using a fish-eye projection. Up to a 180-degree field of vision can be captured. However, the final photograph looks highly distorted and looks like a photograph of the scene as if reflected on a silvered ball. It may be that the name of this type of lens comes from what one imagines a fish sees underwater, or that the image is distorted around a central point, much like what a fish eye looks like. Telephoto lens. Telephoto lenses 100mm to 800mm can provide you with a narrow field of view. These long lenses enable you to compress a distance and compress the sensor depth as well, and pick out specific objects from far off. They have a strong resolving power and an inherent shallow DOF, where the slightest lateral movement can take the subject out of view. Telephoto lenses are great for wildlife, portraits, sports, and documentary types of photography. They enable you to capture subjects from hundreds of feet away. Telephoto lens. Perspective. When you think about landscape photography, you might immediately think of the wide-angle zoom lens, which is great for capturing those expansive landscapes and taking it all in. But a telephoto zoom lens can also be helpful when photographing landscapes. To understand why, it is important to know what determines perspective and how perspective can help convey a particular feeling in a photograph. Conclusion. In this chapter, we have covered the following in detail: drive, film transport, gate, lenses, back focus, claw and registration, components and properties of camera, basic principles of photographic representation, close, long shots, response function of a camera, CCD cameras, 1 CCD, 3 CCD, etc., and their usage, optical and geometric properties of lens, depth of field, basic structure, pinhole camera model, wide-angle lens, telephoto lens.